Hi, I'm Jason Mears, and this is Public Cloud for VMware Users 102, Compute and Services. So in this section, we're going to cover processing power, that's CPU and memory or RAM. We're going to cover storage or local storage rather than network storage, graphics cards or GPUs, graphics processing units, databases, machine learning and artificial intelligence, developer tools, and media and content. So for all the stuff we're going to cover in this video or this section, I'm going to use the Cloud Console in Google Cloud Platform or GCP because that's the one I'm most familiar with. All of the cloud providers have a web-based console for accessing products and services. This is the default one for Google Cloud Platform. You'll notice in the top corner there's a little button there to get the menu. Apparently that's called a hamburger because it looks like a hamburger. I didn't make this up. And just as an example, you'd click the hamburger, then you click the section that you want to go into to get to that particular part of the web interface. So in this instance, I've clicked on Compute Engine. If I don't already have any VMs, it'll prompt me whether I want to create, import, or do a quick start. So I'll just click on Create. And at this point, I'm now starting to pick and deploy computing resources or consume computing resources. So for this first one, most times when you pick a new virtual machine, the compute, the memory and the storage will be done through the same interface. So I'm going to do all of these three together. And just as an example, I'm going to show you three screens. It's the same screen, I'm just using a different tab on every one of the images. So on this example, I'm using the general purpose tab. The next two screens will be the memory optimized and compute optimized. But just to show you here that when you pick a general purpose VM, there's a concept of a series, a type of virtual machine, and then the specific ratio of CPU and memory. So in this instance, I'm using a type N1, a standard machine that has 1 vCPU and 3.75 gig of memory. If I was to click on the memory optimized tab, I'd get a different set of VMs, which are, surprisingly enough, memory optimized. They've got more memory ratio in comparison to CPU by clicking on that tab. And then compute optimized, where the ratio of compute to memory is higher in the favor of compute. So just an example there on how to build a virtual machine, and that there's generally a general purpose, a memory optimized, and a compute optimized version. Just to take that a step further, what you might find on some cloud platforms is that you can pick specifically the type of processor. And you can say it must be this type of processor, or it must never be lower than this kind of processor. Just if I look through some of these custom ones as well, you can see I can do micro, tiny little virtual machines that actually share resources with so one processor core might be shared amongst multiple machines, so these really are micro or small. And at the other end of the scale, we've got ultra memory, so these things have got 160 vCPUs and almost 4 terabytes of memory. So just to show you the different options there. The next thing we might want to add, if we had a virtual machine, is we might want more specialist graphics cards or GPUs. Now that might be to improve graphics performance, or it might be to use services such as AI and machine learning. Although there are other ways of doing this, graphics cards are traditionally used for those video stuff as well as AI and machine learning. So if I optionally add another GPU, I could pick from the list, most common being the NVIDIA Tesla. So I might say I'll have this particular GPU and I'll have one of them or two of them or three of them or four of them. The other thing we might want to do is enable virtual workstation, or what's otherwise known as NVIDIA Grid. So that's a technology for carving out parts of a graphics card so that it can be used for more than one user or for more advanced graphics technologies. What I will say is if you're interested in NVIDIA Grid but you don't know much about it, I do have another series of videos called NVIDIA Grid on VMware. So that's an 8-part series starting from the very basics. So if that's of interest, maybe check out that set of videos too. Next thing you might want to have a look at is databases. So again, from the same console we saw before, I clicked on Cloud SQL. SQL being the most common name for databases, relates to the structured query language that you use to ask a database questions. So if I was to click on Create Instance, in Google Cloud Platform, under this category, there's three different types of database: MySQL, PostgreSQL, and SQL Server. So in this instance, I'm going to pick MySQL. As soon as I pick that, it will ask me for some information, how I want to set this database up, so something like a name and a password. But the reason I'm really showing you this screen is you'll see down there we've also got region and zone. So we talked about this in a previous video, but when you deploy something in a cloud environment, the hierarchy is the world is divided up into regions, and regions are divided up into zones. So on that one where it currently says US Central, if I click on that, I could pick a different part of the world in which to deploy this, and once I've picked the region, based on the region, I could then pick a zone within that region. So this is how you pick where your compute resource or where your database or any other compute resource or service is going to reside. So another thing on here is machine learning and AI. So we're now getting again into more the services that you can add to your virtual machines or your compute platform. There's quite a lot going on with machine learning and AI with all the cloud providers. Far too much to cover in an entry-level video like this. So all I will say is there's quite a lot of specific sections or AI hubs with each cloud provider. And what you'll generally find is some getting started stuff and details on how to train models and how to predict what things are going to do once you've got a model. As I say, far too advanced for this level of video. Just know that the ability is there. DevTools, another major reason why people would look at a public cloud provider, just because it's primarily focused on developers deploying code and apps as quickly as possible. So lots of the public cloud providers will also partner with other organizations or commercial companies or open source products. So you can also add additional third-party products to your cloud environment if you wish to. Example here is Redis Enterprise. Another example here is something we call a cloud shell. So on Google Cloud Platform, I can open something called a cloud shell, which is like a command line or an MS-DOS prompt, if you're old enough to remember those, but basically a command line interface inside your cloud environment. In this instance, I've cloned the code for Spinnaker, which is a CI/CD deployment tool. Once that's built, I'll have a graphical interface like this. I've picked this pretty picture because most of the command line tools are exactly that, command line, and not much to look at. But this is a tool for deploying software in the cloud with a view to automatically building the software, testing the software, deploying it, and if it works well enough, deploying more of it, or if it works badly, removing it and reverting back to the old version. So just an example of the kind of things and the kind of dev tools you get in the cloud. So lots of cloud providers also have additional services around media and content, and previously this was always about delivering videos or audio or images and content delivery. Most of the new, certainly most of the more interesting media and content services tend to be things around automatic machine learning, where the cloud provider has trained machine learning to recognize things in media. So to recognize objects in photos or video, or even recognize language and speech. Let me give you an example of that. We could take on one of these media and content services using something called AutoML, and I can give it a video, and the AutoML is clever enough to know that that is a truck or a lorry on a road, and it's clever enough to identify what that is from just the video footage. Now, some of this AutoML is not only capable of just recognizing it's a truck, but it's capable of recognizing that it's a car, or what type of car, or that this is two cars next to each other, not a big car. So once you can do this kind of classification using machine learning, other things you can do then is give it some video and say, tell me how many of each type of car or type of vehicle you saw going past on that footage. So again, just an example of some of the newer media and content services available with cloud providers. So if we were to build something inside a public cloud, I might want some compute and some storage. The most sensible thing to do first, and in fact sometimes it's a requirement, is to build something called a VPC, or a virtual private cloud. This is nothing more than a logical grouping of all your stuff in one place. So we tend to deal with a VPC and put things inside of it. So here's my VPC, the first one I've created. If you're a small user or a beginner, you probably only need one virtual private cloud. If you're a large organization with lots of different projects and teams and departments, you might even create a VPC per department, per team, per project. But for us, just starting out with this, a single VPC is going to be fine. It's just somewhere to put our stuff. So once we've got that VPC, we probably want to have some kind of networking inside. And if we've got one set of networking, why not have multiple bits of networking? Again, this networking only is present inside the VPC at the moment. So only things inside the VPC can see the VPC. Now I might add more resources. Again, it's cloud computing, so I can have bigger, smaller, more or less, however I feel like deploying this. So I've now got lots of different compute and storage and networking inside my VPC. The next thing that I might want to do is some kind of identity and access management, something called IAM. And this is the way that the stuff inside the VPC can be connected to by external networks or other cloud services. So IAM, identity and access management, is the bit that does the identity and security between things in and out of the VPC. So to put it in simple terms, inside the VPC are compute resources, and those compute resources are managed through IAM to other cloud services or to other external networks or other external access. Again, if I was to summarize that, I would say this is where we group all of the things together in the VPC, and this is where we control access to the VPC. So just skipping on from that, and we're coming to the end now. If someone was to ask you as part of an elevator pitch, what is a VPC? What I would say is it's a virtual private cloud, and it's a logical grouping of compute, storage, and network resources that can optionally be connected to other cloud services or networks. So it's a place to put all the stuff, whether that be compute, storage, or networking. Next question, what is IAM? IAM is identity and access management. This can control which users, networks, and other cloud services can communicate with each other. Usually, or specifically, what users, networks, and other cloud services can communicate with a particular VPC. And if you're struggling with all these terms and acronyms, one hint is if you remember the phrase "I am allowed, you are not allowed," that might help you remember why we call it IAM. Because it's there just in the text. I am allowed, you are not allowed. It's all about identity and access control and management. So that was the end of that particular video. Next time we're going to look at video 103, computing resources and services, but in particular the workloads that we actually run on our cloud platform or on the resources inside our VPC. So that's 103, computing resources and services, workloads. Thank you very much for your time, and I hope you found that useful.